Assalamualaikum warahmatullahi wabarakatuh. Our final year project is minimizing travel distance for tourism using KRUSKAL'S algorithm and DIJKSTRA'S algorithm. This project is under the supervision of Dr. ROSSIDAH BINTI Abdul Aziz. Assalamualaikum and hi, my name is NORMASTIKA binti Baharudin.
Hi, my name is Aina Adawiyah binti Muhammad ELHAMUDDin.
Hi, Assalamualaikum. I'm SHAMIMI BASRI.
Abstract. In tourism, route planning is important to compute the most cost-effective route involving several locations by minimizing the travel distance. In this study, two shortest path algorithm, KRUSKAL and DIJKSTRA algorithm, were implemented for the purpose of finding and minimizing the shortest path among the selected places of interest. Data of 20 selected tourist attractions was computed into the Python software to obtain the result of the suggested shortest path for both of the algorithms. The exponential model was later applied to verify the result of the algorithms by comparing the root mean square error values for both of the algorithms. This study resulted in KRUSKAL'S algorithm being the most efficient method in minimizing travel distance, cost of fuel, and travel time compared to DIJKSTRA algorithm. This statement is strongly proof as KRUSKAL'S algorithm has the smallest value of error measure. Introduction. Tourism is associated with cultural, social, and economic phenomena that involves traveling to areas beyond the natural settings. Tourism is Malaysia's biggest and fastest growing sector that brings long-term impact to the economic growth, country development, and other related service sectors. In tourism, tourists always start to minimize their travel distance as much as they can due to the limited allocation of time, cost, and budgets. One of the solutions for this problem is by finding and determining the shortest path and optimal routes. This can be achieved by applying the graph theory, where it uses the shortest path algorithm. In this study, two of the algorithms, namely KRUSKAL and DIJKSTRA algorithm, were used to determine the efficient model and finding the shortest path. Both of the algorithms used is algorithms that do not create a cycle in its result, which means in this study, the tourist will not repeat the same destination twice. Problem statement, objectives, and significance and benefits. The problem that tourists face during traveling is that there are too many attractive places that they can visit, too many ways, paths or routes to go from one place to another, and tourists, especially international tourists, have insufficient knowledge regarding the tourism places. This problem may cause an increment in tourist budget allocation and will consume a longer time during traveling. Consequently, tourists will not be able to experience as many places they are interested in. However, the problem can be solved by determining the shortest distance of route during their travel time. Therefore, KRUSKAL and DIJKSTRA algorithm were chosen for this study as it has been noticed in the previous study carried out. Although there were many research on those two algorithms, there was a lack of study on which algorithm was better in determining the shortest path. Hence, three objectives were both. First, to identify the shortest distance between the selected tourist attraction by using KRUSKAL'S algorithm. Second, to validate the result of KRUSKAL algorithm with DIJKSTRA algorithm. And the last one, to determine the efficient method between KRUSKAL algorithm and DIJKSTRA algorithm.
Significant and benefit of this study is that the algorithms used is advantage where the path generated will be in minimum risks, cost, and distance. This study will help in reducing tourist stress for making decisions in choosing which route and path to be used so that all the tourism attractions can be visited. It also will ease the tourists by assisting them in planning their trip in a more effective and efficient way. This study also believed to enable the tourists to optimize the time together with traveling distance while reducing the cost during the travel journey. Moreover, this study will encourage and lift up the tourist staff's confidence level throughout their travel journey.
Scope and limitation. Scope. This study focuses on finding the shortest path for tourism among 20 selected tourist attractions in Penang. The data of distance and time used was collected from Google Maps, while the fuel assumption cost was taken from the cost of RON95 fuel at the moment the study was conducted. This study also used Python to run the data and Microsoft Excel in finding the RMSE values. Limitation of the study. This study is limited on only comparing two of the shortest path algorithms in finding the shortest distance and travel time without considering the traffic condition and tourist opinions. Besides, the study also focuses on the tourist attraction in the city of Penang.
Shortest path problem involved in finding the optimal path between a vertex and all other vertices in a graph. Total distance traveled, cost, and time consumed are the measurement of the effectiveness of the shortest path problem. To solve this problem, it is encouraged to use algorithms such as PRIMS, KRUSKAL, DIJKSTRA, Floyd, Johnson algorithm, and many more. In this study, we implemented and compared two of the shortest path algorithms to find the shortest route in minimizing the travel distance for tourism. First, KRUSKAL algorithm. KRUSKAL algorithm was implemented by Joseph KRUSKAL in 1956. This algorithm is used to identify the minimum spanner tree for connected vertex graph. KRUSKAL is known as a greedy approach due to its main target in choosing the shortest distance first without considering the probability of the existence of other optimal paths. Next, DIJKSTRA algorithm. DIJKSTRA was developed by Edgar W. Dijkstra. The function of this algorithm is to determine the shortest route from a node to another node in a graph. DIJKSTRA has been widely used in routing systems, subroutines in advanced algorithm, flighting agenda, mapping, and many more. Application of KRUSKAL algorithm. This table mentions the previous study that applied KRUSKAL in their research, we can summarize that KRUSKAL has been widely used. For instance, it is used in the problem of optimization routing, determine the optimal route to the construction store, modify KRUSKAL algorithm in multicast routing, solving radio resource allocation problem, and others. Next, the application of DIJKSTRA algorithm. These are the example of previous study that used DIJKSTRA. DIJKSTRA was widely used in determining the shortest route, creating a website-based and application, optimal route selection system, vehicle evacuation purpose, and many more. DIJKSTRA algorithm also was improved for sparse network study. Next, methodology. There are three main phases that involved in this study. First, data acquisition. The data for the travel distance of each tourist attraction was obtained from Google Maps. There were 20 tourist destinations in Penang that were randomly selected as in this table. These data were used as inputs in Python for analysis. The destinations were then labeled as 0 to 19 for the implementation. In phase 2, KRUSKAL algorithm was used to find the shortest distance between the 20 selected tourist attractions. This figure portrays the process of finding the shortest distance using KRUSKAL, which contains 6 steps as follows. Step 1. Compute the distance for every tourist attraction's value HE of vertex V, where V is equal to 0 until 19. Step 2. Sort the distance in ascending order and store them in a list or table form. Step 3. Select pair of tourist attractions with the shortest distance traveled. Step 4. Connect the tourist attractions if these two conditions are met. Condition 1. An attraction can only be connected to at most 2 attractions, which are the previous and the next attractions. Condition 2. A subgroup of attractions should not form any cycle. In step 5, reject the pair of attractions from the list if any of the two conditions are not met. Lastly, the algorithm then repeats step 3 until there are vertex V minus 1 edges and form the best route. Next, phase 3. In this phase, DIJKSTRA algorithm was used to validate the result obtained from KRUSKAL by comparing both of the algorithms. In operating DIJKSTRA, it always starts with a fixed starting point. Next, the starting point will then be connected to the rest of vertices in the graph. Step of DIJKSTRA algorithm. A n by n geometry is described as a weighted diagram G of n vertices as this equation. D is distance from tourist attraction to the next attractions. Meanwhile, the ij refers to the distance of directed h from vertex I to vertex G. Every vertex in the diagram is labeled. There are some vertices has been labeled as permanent, meanwhile the other vertices are labeled as temporary. In step 1, assign the starting vertex as a permanent label, which is value of 0. Step 2, assign the other remaining n-1 vertices with temporary label, which is infinity. Step 3, give a new temporary label to every vertex j, which is not permanently labeled yet, where the value obtained using this formula. Step 4, compare all the value of temporary labels, hence choose the smallest value, which it will become the permanent label of the corresponding vertex. In the last step, repeat step 3 and step 4 until destination vertex T will become a permanent label. Next, the verification of the result using RMSE. In order to know the best method to use between KRUSKAL and DIJKSTRA algorithm in finding shortest path, RMSE can be applied. RMSE, or root mean square error, is the standard deviation of the predictions errors. It is a good method to measure the accuracy when comparing the prediction errors between the several different models. This is the formula to calculate RMSE. RMSE was used to calculate the error measure for both KRUSKAL and DIJKSTRA algorithm. The value of RMSE for both methods are then being compared, and the lowest value indicates the better method. To obtain the RMSE value, exponential model is also applied in this study. This is the equation of exponential model, which was obtained from Hogan 2019.
Next is the result and discussion. This shows the graph plotting and adjacency metric for all tourist attractions in Penang. On my right hand side, it is shown the network graph of all possible routes among the tourist destinations in Penang. In the network graph, there are 20 vertices that represent tourist destinations. Meanwhile, the edges represent all of the possible routes that connect one destination to another. The network graph was used to find the adjacency metric of the 20 tourist destinations as shown on my left hand side. As we can see, 1 in the adjacency metric was represent the routes that connect one destination to another, while 0 represent there is no route connected. To obtain the result, Python software was utilized in model computation. The distance between the 20 places was input into the Python software. Hence, the result generated from the KRUSKAL algorithm was used to construct the minimum spending tree, which is obtained as this. As we can see, this is the minimum spending tree route using the KRUSKAL algorithm. The total distance traveled is 82.933 kilometers. The travel time is 3 hours and 20 minutes, while the cost of the fuel is 11 ringgit and 80 cents. For the fuel, we use RON95, which is the price is 2 ringgit and 5 cents per liter at the moment of this study was carried out. Next, we validate the KRUSKAL result by using DIJKSTRA algorithm. The same data of 20 places was applied to DIJKSTRA algorithm to find another shortest path and distance for traveling in Penang. Once again, Python software was utilized in this model computation. Therefore, using the result obtained by the DIJKSTRA algorithm, we obtain the minimum spending tree graph for the shortest path like this. As we can see in the graph, node 0 is CONT and 9 is Penang National Park are the terminal nodes. The total distance is 125.433 kilometers. The total time travel is 3 hours and 57 minutes, while the cost of fuel is 21 ringgit and 32 cents. To sum it up, this table shows the comparison of the result between KRUSKAL algorithm and DIJKSTRA algorithm. Based on this comparison, we can see that KRUSKAL algorithm has the minimum shortest distance, cost of fuel, and travel time compared to DIJKSTRA algorithm. Nevertheless, we need to verify this result using root mean square error to identify the most efficient method among the algorithm for finding the shortest distance travel. Exponential model is one of the models that we use to find the error measure. In this table, it represents the comparison of the RMSE used obtained for both algorithms using exponential model. From here, we can see that the error measure for KRUSKAL algorithm is 8.45, while DIJKSTRA algorithm is 14.66. It shows that KRUSKAL algorithm has the smallest value of the error measure compared to DIJKSTRA algorithm. Hence, from this, we can conclude that KRUSKAL algorithm is the most efficient method in minimizing travel distance, cost of fuel, and travel time for tourism in Penang compared to DIJKSTRA algorithm. As the conclusion, KRUSKAL algorithm has the minimum shortest distance, cost of fuel, and travel time. It proved by the verification of both algorithm results by using RMSE in order to determine the most efficient method among the two algorithms, where the result shows that KRUSKAL algorithm has the smallest value of error measure compared to DIJKSTRA algorithm. The total distance traveled is 82.933 kilometers, traveling cost is 11 ringgit and 80 cents, and travel time is 3 hours and 20 minutes. For the recommendation, it is recommended that the further study conducted in the region or entire country to include more tourist destinations and also try to look at the overall travelling cost involved. Furthermore, it is recommended to the Penang Global Tourism and other travel agents and tour guides to adopt this study as a basis for developing information such as database of distance between the various tourist destinations to advise the tourists about the destination that they want to visit. Thus, it can reduce the amount of time travel and fuel consumption during their tour. Lastly, it is recommended to use the other algorithms such as traveling salesman problem, price algorithm, and other available methods.